Now in this sum they have given us that x cos theta plus y cos theta plus 2 pi by 3 is equals to z cos theta plus 4 pi by 3. If this, they have given you this relation and they have said to prove that xy plus yz plus zx equals to 0. So what I'm doing here is I'm taking this as k. So we are getting cos theta is k by x, cos theta plus 2 pi by 3 is k by y, and cos theta plus 4 pi by 3 is k by z. Is it clear? Now I am adding the corresponding sides. So k by x plus k by y plus k by z will be equals to cos theta plus cos theta plus 2 pi by 3 plus cos theta plus 4 pi by 3. Is it clear? Now I am opening the brackets by using the formula of cos A plus B. So what we are going to get? In this case, even if I don't open the bracket, you do one thing. You treat this thing as your C and this thing as your D and apply cos C plus cos D formula. So what we are going to get? Cos C plus cos D, 2 cos C plus D by 2. C plus D by 2 cos C minus D by 2 cos C minus D by 2. Is it clear? So cos theta plus 2, actually cos C minus D by 2, this theta and theta will go off. So in this case what we are getting basically, here we are getting it as theta plus pi, and in this case we are getting cos pi by 3 minus pi by 3, but doesn't matter because cos of minus theta is always cos theta. So what we are getting here, cos theta, cos 180 plus theta is minus cos theta, so it will give you minus 2 cos theta, and cos 60 degree is nothing but half. So we are getting what? Cos theta minus cos theta, which will give you 0. Is it clear? So we are getting k by x plus k by y plus k by z is nothing but 0. Now if I take k common, look at carefully. If I take k common, so we are left with 1 by x plus 1 by y plus 1 by z, and which is equals to 0. Is it clear? Therefore if I take the LCM x, y, z, so in the numerator we are going to get yz plus xz plus xy, and this k will come down, so it will become 0. So your xy plus yz plus zx will be equals to 0, because if we cross multiply with xyz with 0, that will give you 0, right? Therefore we have proved that xy plus yz plus zx is nothing but 0 for this problem. Have you understood this? Absolutely. So in this problem they have given us that a plus b plus c is pi, and sine a plus c by 2 is equals to n sine c by 2, and we have to prove that tan a by 2 tan b by 2 equals to n minus 1 by n plus 1. Okay, now if you see the proof part, you can easily understand that how to approach the sum. Can you see that in the proof part they have given you n minus 1 by n plus 1? So naturally this sum demands your componendo and dividendo method. Yes or no? Okay. So what I will do here is, I will straight away take sine c by 2 in the denominator, and in the right hand side we are going to have n minus 1, and if we apply now componendo and dividendo, then in the right hand side you are going to get n minus 1 by n plus 1, and in the left hand side we are going to get sine a plus c by 2 minus sine c by 2 divided by sine a plus c by 2 plus sine c by 2. Is it clear? Now, in the numerator, we are using the formula sine c minus sine d. So, we are getting 2 cos c plus d by 2, c plus d by 2 sine c minus d by 2, which is nothing but your a by 2, divided by sine c plus sine d, which is nothing but 2 sine c plus d by 2, c plus d by 2 cos c minus d by 2, which will give you a by 2. So what we are getting? In the right hand side, we are getting this thing as your tan a by 2. And for this one, cos a plus c by 2 plus c by 2. C by 2 plus c by 2 will give you c. So it is a plus c by 2. It is nothing but a plus c by 2. I'm sorry, this is a by 2. This one is cos a plus c by 2. And in the denominator, we are getting sine a plus c by 2. Is it clear? So we are getting basically what? Tan a by 2 cot a plus c by 2. Is it clear? Cot a plus c by 2. Now we are having that a plus b plus c is pi. So in place of a plus c, I can write pi minus b. So what we are getting? Is it clear? So cot 90 minus theta will give you tan theta. So which will yield tan a by 2, tan b by 2. Proved. Is it clear? So this is how we have approached the sum. How I came to know that I have to approach by this method? Once you see in the proof part that there is n minus 1, n plus 1. So first thing that will strike in my mind is to go for component and dividend. Is it clear? So try to approach the sums. Just keep this thing in your mind that whenever I see this kind of form, I should go for component and dividend, right? In this sum, they have given us that two different values of theta are theta 1 and theta 2, and both theta 1 and theta 2 are lying between 0 and 2 pi. Okay? And they have said that sine theta plus phi is equals to half sine 2 phi. Okay? And we have to find out, we have to prove that sine theta 1 plus sine theta 2 divided by cos theta 1 plus cos theta 2 is equals to cot phi. This we have to prove, and we have given this, and they have said that two different values of theta are theta 1 and theta 2, where both theta 1 and theta 2 are lying between 0 and 2 pi. Now, since we have two different values of theta, which one is theta 1 and another one is theta 2, so we can write, in place of theta we are writing theta 1 plus phi equals to half sine 2 phi, or you can write sine theta 2 plus phi is equals to half sine 2 phi. Am I correct? Both these are equal to half sine 2 phi. Therefore, we can say sine theta 1 plus phi equals to sine theta 2 plus phi. Hello? Is it clear? Now you observe carefully. Sine A, think about it. Sine A and sine B, they are equal. If I tell you that A and B are lying between 0 and 2 pi, let us say. So in that case, sine A equals to sine B. When two sines are equal, either it can be in the first quadrant or it can be in the second quadrant, right? Even if I say you cos A equals to cos B, where cos are equal, two angles are equal, cos A will be equals to cos B. When it happens, either it is in the first quadrant or it is in the fourth quadrant, right? And in case of tan, either it will be in the first quadrant or in the third quadrant. So sine theta 1 plus phi equals to sine theta 2 plus phi. This can happen either it is in the first quadrant or in the second quadrant. Let us assume that it is in the first quadrant. Then we will have theta 1 plus phi equals to theta 2 plus phi, right? So from here we are getting theta 1 equals to theta 2. But they have said that theta 1 and theta 2 are two different values of theta. So this value we cannot take. So we will say that sine theta 1 plus phi equals to sine theta 2 plus phi. It means that theta 1 plus phi must be equals to pi minus theta 2 plus phi. Have you understood this or not? Because within your 0 to 2 pi, these are the two values, 2 points, or you can say 2 quadrants where your sine will be equal. So in this case we are getting theta 1 plus theta 2 equals to pi minus 2 phi. Is it clear? So this is exactly what we got. Now let us come to the proof part. We have been given, we have to prove that sine theta 1 plus sine theta 2 by cos theta 1 plus cos theta 2 is cot phi. Let us take LHS. And if we apply sin C plus sin D formula, so we are getting 2 sine C plus D by 2 cos C minus D by 2 divided by, we are applying cos C plus cos D formula, 2 cos C plus D by 2 cos C minus D by 2. Cos goes off, 2 goes off, so we are left with tan theta 1 plus theta 2 divided by 2. Is it clear? Now theta 1 plus theta 2 is nothing but pi minus 2 phi. So we can write this thing as tan pi minus 2 phi divided by 2. So we are left with tan pi by 2 minus phi, which gives you cot phi, which is nothing but your right hand side. Is it clear? Have you understood this conception? Have you understood the problem?